Go ahead and pause and copy this, but I'm going to start scooting it down, highlight some topics here. This is what's called the vertex form because it gives us this point right here, which is the vertex. Okay, so that HK shifts the parabola. This is basically graphing parabolas. Okay, and so we know a parabola either opens up or down, kind of U-shaped. We've seen these before, but we want to be able to graph them more quickly and accurately using some techniques here. So when we have a point H and K that's put in this form, it shifts the graph horizontally and vertically. H is our horizontal shift, so that's convenient. They both start with H. The weird thing about H, and actually if you go further in mathematics, this is pretty normal. The K is the weird one, but for now H is going to seem weird to you, is that if it shifts to the right, the H is negative, left, the H is positive. And we'll see that. I'm not just telling this to you, but we'll actually go through some examples. The K is going to seem the more normal to you at this point, meaning what? It's not opposite. So if it's a positive K, it shifts it up. A negative shifts it down. We'll see that as well. We know more than just the vertex from this form. The A tells us about the graph. If the A is positive, then the graph opens upward. So that's what that A value does. If the A is negative, it makes the graph open downward. So this would be like a parabola opening upward, and this would be a parabola opening downward. The word we use for that is creates a reflection. Okay. If we go on to what else do we know? Actually, that's going to mostly be it. What you need to be able to do in your homework is find the vertex, know if the graph opens up and down, and then find another point around it. And you should be able to do everything you need for the homework. This little extra part I am going to show you. I'm not going to make a big deal about this, but basically you can also find the x-intercepts from this form. So it's a very versatile form. I don't have to use some of the previous skills. If I can get something in vertex form, I literally can just set the equation equal to 0 and solve it. And I'll either end up with 2 x-intercepts, 1 x-intercept, or 0 x-intercepts. And we've already kind of started seeing this in previous sections. But I'll show you how you can do this near the end. But this is not going to be something I'm not really going to be testing you on. So what you need to really focus on is 1 and 2, knowing the shifting, knowing if it opens up and down. And then basically you're going to plot points around that vertex, and that'll give you enough to do that in the homework and the test. Okay, so let's start with the parent graph. A parent graph is the simplest form of an equation. So basically, if I have no A's, no H's, no K's, nothing complicated going on, I'm just graphing x squared. What does that look like? And we've seen that before, and if you're not sure, you should always be able to plot the points. So I'm going to go ahead and choose some numbers to the left of 0, like -3, -2, -1, and then some numbers after 0, like 1, 2, and 3. And this should be enough to give us a pattern to kind of know what this graph looks like. We can start with some easy numbers. If I plug in a 0, f of 0, 0 squared is 0. Remember, this is our x and this is our y, or our f of x, right? So we have a point 0, 0. If I plug in a 1, f of 1 is 1 squared. 1 squared is just 1. That's our y value. 2, you're like, oh, this is easy. It's just 2. No. Check it out. Plug that in for the x. Put 2 squared. That's not 2. That would give us 4. See, this is not a straight line. A parabola is not a straight line. We already said it was going to be curved, right? And if you're not sure yet, try f of 3. 3 squared would give us 3 times 3, or 9. Now the key here is what happens when I plug in the negatives. Well, f of -1. When I do -1, and the key here is that the whole thing is being squared. This literally means -1 times -1. And a negative times a negative makes that a positive 1. See, so we have 0, 1, 4, 9. 0, 1 is also positive. This -2, when I square it, is also still going to be a positive. So this creates a reflection around this point right here in the middle. Okay. And -3 squared, that'll also be a positive 9. So it creates a pattern here around the center. There we go. And this center point is called our vertex. It's the middle of our parabola, and it creates kind of the reflection around it. You can see literally algebraically how the numbers reflect around that middle point. So we have, let's say, 0, 0, 1, 1, 2 goes all the way up to 4, and 3 goes up to 4, 5, 6, 7, 8, look like way up here. So the idea is, as I go to the right, it's rocketing upward. It's growing exponentially. When we go to the left, -1 gives us 1, -2 gives us 4, -3 gives us friggin' 9 all the way up on the screen there. But the idea is that there's a reflection around this vertex. So this is the parent graph. This is the one that you need to have in your head. If I graph x squared, I should be able to graph that quickly and accurately. If you're not sure, plot some points. But at this point, I'm going to be using this graph to build all the other graphs from it. That's why it's called the parent. It's kind of where the graphs begin, like. Okay? So, let's see. Quick definition. Our vertex is either our highest or lowest point on the graph. It's also the point of symmetry. It's in the middle. It is, in the previous example, it was the lowest point because this was a parabola opening upward. If a parabola is opening downward, it will be the highest point. Okay? All right, onward. What happens if I stick an x minus 2 squared? Well, that's going to change the graph, right? Now I have an x minus 2. Is that an h or a k? Well, that's right there in that formula. So this is an h, okay? This is going to be a horizontal shift. Worst case scenario, you should know how to plot some points and see what this looks like. So that's what we're going to do. But the goal is, by the end of this, that we can do this quickly and accurately without having to constantly plot points over and over, okay? So here is our parent graph up here. That's our parent graph, PG, okay? What happens when I plot some points here? For instance, let's try 0. Well, f of 0 is no longer just going to be 0 squared. It's going to be 0 minus 2 squared. 0 minus 2 is -2. -2 squared is positive 4. This graph is different, isn't it? Do a 1, f of 1. 1 minus 2 is, how about -1 squared? Positive 1. Some of these numbers look very similar, don't they? Let's try a 2. 2 minus 2 squared is 0 squared, which is 0. This 410 matches the 410 right here, doesn't it? See what happens when we plug in a 3. 3 minus 2 is, how about 1 squared? 3 minus 2, which is 1. I see some symmetry. 4, 1, 0, 1. I'm going to predict this next number should be a 4 if there is symmetry here, right? So if you're not sure, we could throw a 4 on there and go 4 minus 2 is 2 squared, which is 4. So we have our symmetry. The thing here is that our vertex is no longer at 0. The symmetry is now shifted what? Well, instead of being at 0, it's been shifted 2 to the right. It used to be at 0, and that -2 made it shift 2 to the right. We end up with the same y values. You end up with the same 41014, okay? We could plug in a negative. You're like, well, what happens if I plug in a -1? Well, -1 minus 2 would be -3, and -3 squared would be 9. So it follows the same exact pattern. It looks exactly like the previous graph. It has just been shifted to the right 2, horizontally 2 to the right. It shifts the x 2 to the right. Another way of thinking about this is basically what gave us a 0 here? Well, 0 squared gave us 0, right? Here, what makes a 0? What minus 2 makes 0? I have to put in a positive 2. That's why the horizontal is opposite this time, because we're looking at basically what makes that a 0, and it changes, okay? So when I look at this, what does this end up looking like? Well, we had 0, 1, 2, 3, 4, okay? We had 1, 1. We had 2, 0. We had 3, 1, and 4 went back to 4. And just for fun and giggles, we put a -1, and we got 5, 6, 7, 8, 9. So what does this graph look like? Well, it looks just like the parent. It literally has just been shifted horizontally, left and right. It's been shifted from here to here. It's been shifted 2 to the right. What if instead of a -2, I'd put a -3 or a -4, right? Well, that's going to make the 0 different. So let's go ahead and look at the calculator and kind of see how this works. That's all the h's. Okay, so here was our original graph, was just f of x equaled x squared. And that was our standard parabola, right? So what happens now is we said, well, what if instead of just x squared, we had x minus 2 squared? And what we said is, well, that's an h, it's a horizontal shift, so all that's going to do is take this same graph and shift it to opposite to the right. What makes that a 0 is not a 0 anymore. Positive 2 now makes that a 0. See, it's the same exact graph, just shifted 2 to the right. What if instead of a -2, we had done a -5? Well, now instead of shifting 2, it will shift 5, still to the right. The horizontal shift is opposite. What makes that 0 if it's a -5 is a +5. By the way, what if instead of a -5, what if we put a +2? What's going to make a 0 this time? What +2 makes it 0? See, it would be a -2. The idea is that that positive h shifts the graph to the left. It's opposite of what you think it would be. So if that h is positive, it's going to shift it to the left. If it's negative, it's going to shift it to the right. Okay? We'll come back to this in a little bit. Let's get back to the notes. Right there. Okay. What if I had an x squared plus 3? Well, that plus 3 is not an h. How do I know? Well, the h, go back to the notes, it was f of x is x minus h squared plus k. The h was the number in there with the x. That number's not with the x. That number's on the outside, so that makes it not the h, makes it a k. What does that do to our graph? Well, we know from our notes, k is a vertical shift. Makes it go either up or down, okay? I have the points again here for the parent graph. Let's see what happens if we plug in some points here. So let's go ahead and do about f of, I'll do the same. So f of -2 still gives us -2 squared. But this time we have a plus 3 on there, right? So that doesn't just give us 4 like it did before. Now it gives us 4 plus 3, which is 7. It's a whole different set of values. What is f of -1? Well, -1 squared plus 3 gives us 1 plus 3, or how about 4? F of 0, 0 squared. 0 plus 3 gives us just 3. F of 1, 1 squared plus 3, or 1 plus 3 is 4. Now this is interesting to me. Look at these numbers down here. I see something. 7, 4, 3, 4. There's symmetry right there. I'm going to predict this next number is 7. If this is symmetry, that means that this number is our vertex, our middle. Okay? So let's double check that too. What is f of 2? Well, 2 squared is 4 plus 3, which is 7, like we thought it was. So what does this k do when we stick it at the end? Notice the vertex here was at 0. Here the vertex is at 0. It has not moved the vertex. The vertex did not move left or right. The x value did not change. What changes with the k is the y value. The vertical, every number is now increased by 3. A 4 becomes a 7. A 1 becomes a 4. A 0 becomes a 3. Literally, it is every of the previous numbers from the parent graph increased by 3. That's all that k does. It doesn't change the x values, it changes the y values. So what does this look like visually? Well, 0, 3, 1, 4, 2, 5, 6, 7, -1, 4, -2, 7. What does this graph look like? It looks just like the parent. It has just been shifted up 3. Literally, the vertex was at 0 and it got shifted up 3. Let's go ahead and look at the calculator again and see how this works. So once again, the blue was our parent graph. What if I took that 2, and instead of on the inside, we put, what did we say, a plus 3. I'm going to predict it will look just like the parent graph, just moved up 3. So instead of the vertex being at 0, it's now at 3. What if instead of plus 3, we put plus 5? Now instead of being shifted up 3, now it would be shifted up 5. What if I put a minus? So what if instead of minus 5, plus 5, we change that to a minus 5? Well, instead of shifting up 5, now it would shift 5 down. The horizontal shift is opposite. The vertical is not. When it's positive, it shifts it up. Negative shifts it down. Another cool way of seeing this, go ahead and get out there. There we go. See this equation right here. Okay. So I'm going to show you what happens when I move this up and down. I actually can grab it. Watch what happens to this number on the outside. As we go up, close to 0, right there. As we continue going up, those numbers, I'm losing it. Sorry, let me pull this out. There we go. The number at the end is positive, right? The number at the end, the k, as it goes up, gets bigger. As it goes down, it gets smaller, 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 bigger negative, bigger negative, bigger negative, right? What happens to this graph as it moves to the right? That h becomes more and more negative. What happens as we move that graph to the left? It makes it more positive. Up, k is positive. Down, k is negative. Right, h is negative. Left, h is positive. Fancy, I know. Alright, I'm going to go ahead and get rid of that graph. Maybe. Okay. Come back to this in a minute. Let's get back to our notes. So now what? We should know the vertex. We need to know how to plot the vertex and then plot some points around the vertex. The vertex is h and k. Don't forget the h is opposite, but that's our first step. Our second step, once I plot the vertex, some points around it, is just to double check the a. We said that if the a is positive, like for instance an x squared, that's a 1 or a positive 1 x squared, that's just our parent graph. The graph opens upward. These are our numbers again from the parent graph. Okay. What if it's negative? Well, all of these numbers still become the same numbers, so I still get the 4, 1, 0, 1, 4, but this time there's a negative weighting on the outside that makes them all negative. Makes all the y values opposite. It flips the graph. If you're not liking that algebraically, I'll double check it real quick. But how about I'll do just the f of, we'll do f of 2. Would be negative, and then the 2 is only being squared. So that would give us negative 4. If we did something like f of negative 2, I would have negative, then the negative 2 squared. So algebraically, the negative 2 would square first, making it a positive 4. The negative on the outside would make that a negative 4. So check the algebra on that, okay? But the idea is that it's the same graph, it's just reflected downward. Okay, so that's what the A does. It reflects it either up and down. Also, it will either stretch or shrink the graph. You'll get this all just by plotting some points. This is really a little more advanced, but if the A is 1, then we have our parent graph. If the A were something like greater than 1, like a 2, okay, then what would that do to all the y values? Well, I would have the same numbers come out. 0 would give me 0, but 0 times 2 would be 0. 1 squared would be 1, but 1 times 2 would be 2. I end up with all the same y values, but that 2 makes everything twice the size. So the 1 becomes a 2, the 2 did make a 4, now it would make an 8. This 9 would become an 18. Everything would be twice as tall as it was before. The negative 1 would now become 2, the negative 2 would become 8. Everything is twice as tall. So visually, this graph looks just like the parent, it's just taller. Okay, we call this stretching the graph. When we stretch the graph, okay, so if this a is greater than 1, we call that a stretch. It makes the graph tall or skinny. Okay, if we have a number less than that, so what if we had a number, oh, where did I go? Sorry about that, I'll get back. What if we had a number between 0 and 1? What that's going to do is shrink the graph. So for instance, if I had 1/2 x squared, then all my numbers get cut in half. So 0 gives me 0, 1 would now give me 1/2, 2 would now give me 2, 3 would give me 9/2 or 4.5. Everything gets cut in half. So what does that do to the graph? Let's see if I can squeeze it in here. Maybe. It makes it 0, 0, 2 till it gets to 1. It makes it wider. Okay, this is called a shrinked graph. Makes it short and fat. Okay, basically that 1/2 makes everything grow half as tall, so it makes it wider, makes it shorter. Okay, and don't worry, the parabola has no emotion, so we're not hurting its feelings as we do this. Okay. But here's the goal. We need to be able to put all of this together, and I'll show you how what you need to be able to do for your homework right now. But the idea is that these are all the pieces that you need to know for 11.6 and 11.7. 11.6, they're just going to be doing one piece at a time, kind of like we did in these notes. 11.7, you're going to see questions more like this. Full credit, right? What do? Well, follow the instructions. The instructions said, first, find out where the vertex is. Find out where the center of this graph is. That's basically our h and k. That's our h and k. Go back to your notes. It's a x minus h plus k. So if this is a minus 4, that makes our h opposite, positive 4. It makes our k the same, 1. What does that mean? I know that the vertex is at 4, 1. I know that this graph, sorry, I keep pushing the wrong button. I know that this graph is shifted 4 to the right and up 1. That's what that tells us. That is the center of the graph. I also know, too, the A is a 3. What that tells me is that the fact that it's positive means that the graph will open upward, and the fact that that's a 3 greater than 1 is going to make it tall and skinny. It's going to stretch it tall. So if this was multiple choice, and I could have some of those, I would choose the one that's tall and skinny, opening upward, and I'm done. For the homework, they're going to want you to plot a specific point. So what did I tell you to do? I said plot a point around the vertex. We got the vertex here at 4. So plot a number around 4, like for instance, how about 5? Plug in a 5 to this equation. 3 would have also been fine. I just like to go to the right and keep it positive. But plug in a 5. What do you get? 3. 5 minus 4 squared plus 1. That's 3 times 1 squared, or 3 times 1 plus 1. 3 plus 1 gives us 4. At 5, it goes to 4. That would be enough to know what this graph looks like. Um, the idea of symmetry is I know that if I plugged in a 3 minus 4, I would get negative 1 squared. That's going to make that positive again. That's going to make it 3 times 1 plus 1. Or that's just going to make that 3 plus 1. Sorry about that. 3 plus 1 is still 4. So I got 3, comma 4. And then basically the technology will graph it from there. Okay? You need to be able to find the vertex. Now notice a second, we knew the graph opened up. We knew it was tall. That kind of showed up here. But that's what we need to see. Let's go ahead and see that in here. Here's the parent graph. And we said, what happens if it is 3 x minus, what were the numbers? 4 and plus 1. Okay. X minus 4 squared plus 1. We said it would look just like the parent, only shifted 4 to the right and up 1. Still opening upward, and notice it's what? A little taller, a little skinnier. It's been stretched. Next one. What if I have a negative 1/3 in front of it? Well, first, we don't worry about all that. We focus on the vertex. Where's the vertex? H and K. Our H and our K are in here. You have to remember the H is opposite. So this will shift, not positive 1, negative 1 on the X, and 2 on the Y. So negative 1 and 2. It will shift 1 to the left and 2 up. From there, I know the graph opens downward. How do I know? Well, the A is negative 1/3. The A is negative 1/3. I know the graph is going to be opening down and wide. That won't be enough for the homework. What you're going to need to do is get another point. So here's the problem, though. If you plot something like 0, you're going to end up with a fraction. How do I know? Well, if we plug in a 0 there, 0 plus 1. So that's not going to actually clear that out. I'm going to end up with, looks like 1/3 plus 2, or 1 2/3. I don't really want to graph 1 2/3, right? So what we do is we're going to plug in a number that's going to create a 3 in there, okay, so that when I can clear out that 3. So basically, I'm going to plug in a 2. How do I know? Well, I want 1 plus something. I want to get rid of this 3, and I have something plus 1. What's going to make a 3 up there? 2 plus 1. So that's going to give us, that's f of, what was it, 2 now, okay? It's going to give us negative 1/3. 2 plus 1 is now 3 squared. F of 2 is going to be about negative 1/3 times 9. F of 2 is going to be 1/3 of 9, about negative 3 plus 2. I feel like I'm messing up somewhere. Guess it's going to be negative 1. So at 2, it's going to go down to negative 1. That doesn't seem right to me. I'll have to double check that. Let me use the technology to do that because that doesn't make sense to me, but let me look at it real quick and then I'll check my algebra. Here's our parent graph. We had this one was, instead of a 3, it was a negative 1/2. Okay. It was a negative 1/2. And then we had, what was this again? Plus 1, plus 2. Plus 1, plus 2. The 1 makes it shift 1 to the right, 1 to the left, sorry, and 2 up. That's supposed to be a 1/3 instead of a 1/2. That should be right now. Oh, it's not as wide as I thought it was going to be. Because, yeah, that is 2, -1. So I see that point right there. Interesting. Okay, so plot some points around it then. I will probably, if I have one with fractions, it would be more like if you know the A is negative and know that it opens up and down, I'll probably have that more like a multiple choice. You'll definitely have some of the homework that'll look a little harder than this. But the idea is that this would be, if I had this on the test, it would probably be more of a multiple choice graph. Okay. There will probably be some in the homework where you need to graph them. Muscle through them. You'll be okay. Okay. One last thing. This is actually a little more advanced, and then you're done with 11, 6, and 7. But this is what you would be doing in the following courses is, what if I wanted the x-intercepts for this? What if I want to know where does this graph cross the x-axis? Well, could I do that from this? What I'd have some people do is they take this and they distribute it all out, and then they'd run it through the quadratic formula, which I think stinks. It's a lot of work. Because this is all ready to solve, okay? So the idea is I can take this equation just as it is, and I can find the x-intercepts if I just set it equal to 0. Set f of x equal to 0. So what I do is f of x becomes 0 equals 3x minus 4 squared plus 1, and I can solve for the x that makes y equal 0. I literally can just set the entire equation equal to 0 and solve it. How would you solve it? Move the 1. Divide by 3. We're doing PEMDAS backwards. At this point, I'm about to square root. The key here is I'm about to square root a negative. What is the square root of a negative? Like, oh, toss it out. No, it's just an imaginary solution. But what did that mean before when we ended up with the square root of a negative? An imaginary solution means that there are no x-intercepts. There are no real x-intercepts. Look at our graph. Does that make sense? This graph never really crosses the x-axis, not in the real plane. Okay? So this does not cross the x-axis. This next one does cross the x-axis. So how would I get the x-intercepts? I could set the equation equal to 0. I may put something like this on the test, but it would be as an extra credit. Sounds like something I would do. Okay. How would I solve this? Well, I could move the 2. Multiply by a negative 3. That's going to make the left side negative 6. The right side, negative 3 times negative 1/3 makes it positive 1. That should be a positive 6. Then I can square root it. Square root of 6 ain't pretty, but it's still there. And I get, let's say, x plus 1 is equal to plus or minus square root of 6. How do I solve for x? Minus 1 on both sides, so that x is equal to negative 1 plus or minus the square root of 6. These are the x-intercepts. When x is negative 1 plus root 6, y equals 0, or when x is negative 1 minus square root of 6, the y value is 0. This would be definitely something I'd be asking you to do, more in a trigonometry or pre-calc. So if that's the direction you're going, get used to this. If you're not, then just, thank Jesus and keep going. You'll be fine, okay? But the idea is, the vertex form is very versatile because it does all of this for us. So this is not something I would put on the test, except I might have something like that as an extra credit. So if you get one like that, take the equation, set it equal to 0. If you can find the x-intercepts, more power to you. Okay? That should be everything you need for 11.6 and 7. Just to recap, the homework's going to start off, I think, pretty fair. It's just going to be doing one element at a time, like I did with the first examples. That's 11.6, so it really is going to prep you one piece at a time. And then when you get to 11.7, that's like the last two examples. Not all of it, just the finding the vertex, having it open up or down, and getting a point around it. That should be everything you need for those two sections. So get it done. You're almost done with Chapter 11. You're almost done with this course. Persevere.